Good morning, this is your stat sensei, and this is our classwork on hypothesis testing, and we're going to run this all the way through using our template. So a nutritionist claims that the average loss for new diet plan is 8 pounds. Well, this sounds like the status quo. So this is and it's a average, so this is probably our population mean. So that's probably our population mean, which is 8, with a standard deviation of 1.9. We've identified that. And a random sample of size 35. You know what? I'm going to write this stuff down here. So mu is 8. Standard deviation is 35. Standard deviation is 1.9. And N is 35. We have a population size of 2,500. That might be important for our N is less than 10%. And an average weight loss of of 8.7. So from our sample, we have a weight loss of 8.7, which happens to be greater than the population mean. Conduct a hypothesis test with an alpha equals 3%. So alpha equals 0.03 to determine the mean weight loss is greater than 8 pounds. All right, so we need to state our hypothesis. That's the first part of it. So HO. Mu equals an HA. And remember, this is always going to be mu equals. Well, traditionally, it's been 8 pounds. And so we want to know if it's greater than 8 pounds. So mu equals 8 pounds. And mu is greater than 8 pounds. Please note, always the population mean, never the sample mean, and these two numbers always must match, and that always has to be an equal sign every single time. So our parameter, we need to define it in context. So let mu equal the true population mean weight loss after dieting. And really, it's dieting on the plan. So I'm going to go ahead and add that for here. All right. The conditions, that's our next part. First one, random sample. And they said a random sample of 35. So of 35, that was given. We can check that off. Number 2, the next thing, we need to check the N is less than 10%. So N equals 35. We always take that 35 and multiply it by 10, which equals 350, which is less than 2,500. So we're good to go there. Number 3, normality. Well, they didn't tell us whether the distribution is normal, but N equals 35, and that's greater than 30. So we can say normal by CLT. Our formula is going to be Z equals X bar minus mu, standard deviation, divided by the square root of N. We need to draw a picture of it. And our picture is going to be something like this. Our mean is the mean, which is the population mean, which happens to be 8 pounds. So our mean was 8 pounds. And we got a sample of 8.7. So that's my X bar. And so we're wondering, what's the probability we get something this extreme or more extreme? And this is my mu. All right, so I need to plug in my values. And we've already kind of gone about labeling them, but we'll make sure that we actually have them. Hold on just a second. So when I go about labeling them, I have a mean of 8, a standard deviation of 1.9, an N of 35, and an X bar of 8.7. And when we look at our shading, we shade it up and to the right. All right, so now we're going to plug into our formula. And so we want the probability that Z is greater than 8.7 minus 8 over 1.9 divided by the square root of 35. And we go to our calculator, and we're going to go ahead and run this thing. So this is going to be a stat test Z test. So stat test Z test. Make sure stats is highlighted because we didn't put a list of data in. Our mean was 8. Our standard deviation was 1.9. Our X bar was 8.7. Our sample size was 35. And we shaded up and to the right, and we press calculate. And we get a Z-score of 2.1796. So we want the probability that Z is greater than 2.1796. And that probability happens to be 0.0146. That's our p-value. So our p-value is 0.0146. And when we look back, we find out that we had an alpha of 0.03. So we plug that in. Make sure they're the same length. And when I do that, 146 is less than 300. So if it's less, if the p-value is less, you reject the null. And then we need to write our conclusion. So our p-value is 0.0146. We reject the null. There is plenty of, enough. I like the word sufficient, so that's what I have. Sufficient evidence at alpha equal to 0.03 to suggest that whatever we define our parameter, and we define our parameter as the true population mean weight loss after dieting, that the true population mean weight loss after dieting is, and this is where we have to look back at our alternative, and our alternative said greater than 8 pounds. So we need to just put that in words, is greater than 8 pounds. All right, so basically we came back, we ran a test, and it's like, hey, you know what? We had a p-value, we calculated a p-value. Our p-value was less than our alpha. So a p-value being less than alpha, we rejected the null. And so based on our sample of 35 people, we determined that the weight loss was not just 8 pounds, it was greater than 8 pounds. Looks like the diet plan is working as claimed or better. All righty, hope you enjoyed, and we'll see you on the next one. Thank you.